In this video, we want to be able to say that I can represent relations and interpret graphs of relations. So first off, what is a relation? A relation, the word itself, makes me think of a relationship between stuff. And that's what it is. A relation is a relationship on how we compare our x values to our y values. Generally, we use an x and y to represent our relations. So relations are ordered pairs where we have x's and y's, and generally speaking, it's multiple order pairs. So we can have several of them. Okay, so we can have x, y as one of them. We can have x2, y2 as another one of them. We could have x3, y3 as another one. It's taking all these ordered pairs and finding some sort of relationship between them. Let's back up just a little bit. Let's talk about what it means for us to have a coordinate system. The coordinate system is our x and y axis. It's whenever we have two number lines that cross each other. Okay? The x axis is the horizontal line. That is this number line. The y axis is our vertical number line. It goes up and down. The coordinate system is whenever we put those two number lines together. That is what we call the coordinate system. The origin of the coordinate system is the center. So the origin is the center of it, which happens to be the point 0, 0, where x is 0 and y is 0. Neither of them are anywhere on the coordinate system. It's just at that center where they cross, where they intersect, those two axes. An ordered pair. You guys should know what an ordered pair is. An ordered pair is just taking our x value and our y value and putting them together. So we have our x value, we have our y value. For example, if we have, let's say, 3, 5, that's technically an ordered pair. We have our x value, which is 3. We have our y value, which is 5. So putting this on the graph, let's actually put it on the graph. We have 3, 5, which would be right there. This is point 3, 5. That is an ordered pair on the graph. It's a place on the coordinate system. The x value, y value, we kind of already have been talking about those. The x value is telling you where it goes on the coordinate system for the x. The y value is telling you where that dot goes on the y value, on the y coordinate of the graph. Okay? So x's is always the first one, y's is always the second one in an ordered pair. Okay? So just to recap, relation. A relation is or can be represented as several different ways. It's a set of ordered pairs. Okay? So a set of ordered pairs is a relation. If we have multiple ordered pairs together, we call that a relation. We are taking a relationship between them. Let's actually look at a few things. Oh, domain and range. Domain is just a fancy word to say, what are the x values? What x values can we have in our relation? So typically we think of our domain as our x values or x coordinates. Okay, what x values are we allowed to have? The range is the y values. What y values are we allowed to have in this relation? So let's actually look at a few examples. There are several ways we can represent a relation. We can represent a relation as an ordered pair or as several ordered pairs together. We can represent it as a table. We could represent it as a mapping, which we're going to explain what that is in a moment. And we can also represent a relation in terms of a graph. So let's say we have, for example, let's say we have a set of ordered pairs. Let's say this set was 3, 5. Let's put another ordered pair, 7, 8. Let's put another ordered pair, let's say -2, 7. Let's put another ordered pair, let's say this one is 0, 0. That's technically part of the relation. Could be. Let's say we have another one at 3, 7. And let's stop there. This would be our relation. These are the points that we are comparing. We could write these points on a table. Remember, the first number in an ordered pair is the x value. The second one is a y value. So we would have 3, 5. We'd have 7, 8, negative 2, 7, 0, 0, and 3, 7. That's how we could represent a relation in terms of a table. We have our x values and we have our y values. In terms of a mapping takes all of our x values, which we call the domain, puts it off to the side, and all the y values, which you call the range, and puts that off on the other side. So let's do it this way. Let's make 2 circles over here, and we're going to map where they go. Let's call this one over here our domain, and call this one our range. Remember, domain is the x values. Range is the y values. So what x values do we have? We have 3 as an x value. We have 7 as an x value. We have negative 2 as an x value. And we have 0 as an x value. We only write stuff down once. We don't have to write down 3 again. Yes, 3 appears in the ordered pairs of the relation twice, but we only have to write it down once whenever we are writing it as a mapping. What are the y values? Well, y values, we have 5, we have 8, we have 7, and we have 0. Yes, there's another 7, but again, we do not have to rewrite it twice. Only once is good enough. Well, now since we have those written down in our areas, in those separate areas, the domain and the range, let's figure out how to map them from one place to the next. Well, 3 can go to 5, or 3 can go to 7. So 3, we just do an arrow pointing to 5. Then we can do an arrow pointing to 7. We're mapping it from one spot to everywhere it can go in the y values, in our range. For the 7 can only go to 8, so we only need one arrow. That goes directly to 8. The negative 2 goes to 7. Negative 2 doesn't go anywhere else. 0 just goes to 0. And 3, again, can go to 7 again. So that is our mapping from one place to the next. We take all of our domain, all of our x values, just make arrows that go from the x values to whichever y values they can go in. Graph. You guys should all know how to graph, but in case we forgot, take our x value, we go 3. For the first one, we go over 3, up by 5. So we go over 3, up by 5. This is 3, 5. We have 7, 8. So 7, 8 be right here. 7, 8. We can have negative 2, 7, which would be right here. Negative 2, 7. We can have 0, 0, which is our origin. 0, 0. And we can have 3, 7. So 3, 7 would be right up here. Remember, x is first. That's our horizontal line. Y is second. That's our vertical line. We go the x value, then we go the y value. That's how we graph our ordered pairs or graph our relation. Look at this example. Express this relation. By the way, we put these curly brackets because we're saying that this is a set of ordered pairs, saying that this is a relation. That's how we notate it. We put the curly brackets on there. So express the relation as a table, graph, and mapping. That's exactly what we were just doing. So let's go ahead and just do the graph first. 3, negative 4. So for this first one, we're going to go 3, negative 4. That's going to be down here. We do the x value first, then we do the y value. 2, 8. So 2, 8 is up here. This is 2, 8. We have, let me make sure I put the color underneath. We have 7, negative 4. So if we go 7, negative 4, that would be right here. 7, negative 4. We can have negative 8, 2. So negative 8, 2 we would have over here. Remember, x is always first. Then we have 8, comma 2, which can be right here. So that would be this represented as a graph. Well, let's do the table. The table is real easy. All we have to do is find our x's and our y's. X is 3, we go to negative 4. X is 2, we go to 8. Let me actually use the correct colors. 2, we go to 8. X is 7, we go to negative 4. X is negative 8, we go to 2. And x is 8, we go to 2. That's this represented as a table. Easy enough. Last part, the mapping. Let's find our set of domain, and let's find our set of our range. So let's put our D for domain, R for range, and we're going to create a mapping of this. So mapping is going to be over here. Let's just make ourselves a little bit more organized. Table and, of course, graph. Okay, domain. Well, we know we have 3 in this domain. We know we have 2 in this domain. It's all the x values. It's just the x values. We know we have 7 in here. We know we have negative 8 in here. And we know we have positive 8 in here. All of those numbers go within that one circle, which is the domain. That's our x values. For our y values, we have negative 4. We have 8. We have, another negative 4, so we don't have to write that down again. We have a 2. And we have another 2. So we only have to worry about writing down negative 4, 8, and 2. We don't have to write them down more than once. So now let's draw our arrows. 3 goes to negative 4, and 3 doesn't go anywhere else. 2 goes to 8. Okay, 2 doesn't go anywhere else. 7 goes to negative 4, so this one's going to map up here. We can have negative 8 go to 2. And lastly, we have positive 8 go to 2. That is our mapping. We have our graph, our table, our mapping. Let's shift gears just a little bit. Independent versus dependent. This is something that will just keep on coming up in all sorts of lessons. Whether it be just this lesson in this class, or whether it ends up being in your science class, or whether it ends up being in another type of class, or whether it shows up in real life. Independent and dependent always shows up because stuff depends on other things. For example, the amount you get paid or the amount you take home for your paycheck is dependent upon how many hours you work, depending on your job. Okay? So independent variable, we typically think of this as our x value. The dependent variable, we typically think of this as our y values. Independent, it can stand on its own. It is not affected by anything else. Dependent, it relies on the information from the other variable, from the independent variable, to get to where we need to go. Okay, let me give you a few examples of this. Let's identify which is the independent and which one's the dependent. And I'm going to use I for independent, and I'm going to use D for dependent, just to try to make it so that I don't have to spend as much time writing. Okay, I for independent, D for dependent. Jimmy works for a small business and earns a certain amount of money based on how many hours he works. Okay, well, we have two things going on. He is getting money. He is getting money for hours, right? Which one would be independent and which one would be dependent? Well, hours, he can't affect how many hours he really works. The time just happens, but the money is dependent upon the time. Okay, so hours would be our independent. The hours he spends working is independent, and the money he gets is our dependent variable. Okay, so hours, that's independent. He can work out however many hours he wants, but his money, the amount he gets paid, depends on the hours he works. And of course, this is not for every job. Some jobs you get paid salary, where it's not based on hours, based off of the job you do. But a lot of jobs are this way, where you get paid for how many hours you work. Here's another one. Andrew is preparing for his math test. He notices that the more hours he studies, the higher his practice test scores become. Okay, well, let's identify what's going on. He's spending some time. He's spending some hours. And he is also finding out a score, right? He's comparing the hours he spends to the scores he's getting. Well, the more hours he's doing, the better the scores. To me, it sounds like the scores are depending on the time he puts into it. Right? Hours, he can spend however many hours he wants. He's not restrained to spend just a certain amount of time. So hours is going to be our independent variables. The hours he studies is independent. Now, I know that you might argue that, well, maybe you have some other factors, that the test is coming up soon. That would be a restraint. Yes, I know that would be. But in this case, the more time he spends is independent, and the score he gets is based on how much time he spends. So that would be our dependent and our independent. So if we were to represent this as a graph, or if we were to try to make this as a relation, the hours we would say would be the x, the scores we would say would be the y value. Okay, independent versus dependent. Let's do a few more just to make sure we have it in the bag. Let's make sure we have this. Identify the independent and dependent variables for each relation. The number of points scored in a basketball game goes up as baskets get scored. Okay, well, we have two things going on. We have some scores. We're making some points. Well, how are we making the points? Well, we're making baskets. We're scoring in the baskets. So it sounds like the score is dependent upon the baskets. Depending on what your score is, will depend on how many baskets you made. We have our independent and our dependent. Make sure you can tell the difference. The air pressure inside a tire increases with the temperature. Okay, well, we're dealing with pressure inside a tire, and we're dealing with temperature. Which one depends upon the other one? Well, the air pressure is increasing as this other thing is increasing. So to me, the pressure is depending upon whatever the temperature is. We can't control the temperature. The temperature is going to do what the temperature wants to do. That's independent. But the tire pressure is going to be affected based off of the temperature outside. So that is why the pressure is dependent and the temperature would be independent. Last thing that we're going to do. Identify the independent and dependent variable for each relation. Okay, well, this is going to be relatively easy because we said that typically our x value is independent, our y value is dependent. So in this graph right here, time is our independent variable. The temperature is dependent. Okay, temperature would be dependent upon the time. Okay, so what we have, for example, as time goes on throughout a day, as the sun comes up, it typically gets warmer. As time moves on and the day moves on, as it gets close to evening, the temperature drops. So that sounds like the temperature is depending upon whatever time it is. Yes, I know that I just said that temperature a little bit ago was independent, but in this situation, it would be our dependent one. Okay, so it can change based off of your situation. So make sure you pay attention to what are the two objects that I'm dealing with. If you're dealing with time and temperature, time, that's independent. The temperature could be based off of that as the time goes on. And in this specific case, we're looking at a thermostat. So let's kind of think of a situation where a thermostat could be doing something like this. So the thermostat, let's say at this point, the thermostat is off. If you turn the thermostat on and it's getting hotter, that means we turn the heater on. Okay, if we turn the heater on, it's going to get warmer inside the building. But as the thermostat goes on, it gets hotter, but eventually it gets to a point where it shuts off. And at that point, it starts cooling off if it's colder outside. And then it kicks back on. Then it just goes back and forth with the temperature depending on how warm it is, depending on what time it is in the day. So the thermostat turns on, it heats up. Thermostat hits the temperature it wants to be at, it shuts off. Time keeps on going, it gets colder, it gets colder. Eventually it's going to get to that point where it's going to turn back on because it's going to be to that point. It heats back up, and it gets colder, it cools back down, heats back up until eventually you shut off the thermostat. That is what this graph is representing. We have the time as if we turned on the thermostat turned on. We hit a point where the thermostat is at the peak where it is hot enough in the house. It shuts off, it starts cooling off. It gets too cold, it turns back on. It gets to that point again, shuts back off, and then it goes back and forth until you shut off the heat or until the temperature outside warms up enough. In this case, we have a drive to the store. So if we're driving to the store, we have the time, which is independent. We can't control the time. Destination or distance, the distance is dependent. How far we are away from something or close to something depends on how much time we're spending getting towards that direction or away from that direction. So that would be dependent. Our time is independent. So if we're driving to the store, let's think about what this situation could be. If we start at home, we're getting farther away from home as we are getting close to the store. Well, let's say there was a stoplight or there was a stop sign. Now you're stopped. You're the same distance from home as you were a little bit ago. Okay, well, let's say that the light continued on. Now we're driving at a slower pace. Maybe traffic's a little bit slower at this point. Maybe the speed limit's a little bit slower because we're not going up quite as fast. So maybe we're driving a little bit slower. Maybe there's more traffic. We stop again. Maybe there was another stoplight. Maybe there was another stop sign. So we stopped at another stoplight, stopped at another stop sign, till eventually we're going to get moving again and make it to the store. So this graph right here, initially we started going at a pretty rapid pace. We stopped, we kept going, we stopped, and we waited for a little bit. Then we started going again. Maybe traffic was bad. We stopped again, and then we get going again as we get closer to the store or farther away from home, depending on how you're wanting to look at it. So that's kind of interpreting this graph. Remember, independent, you can't control. Dependent is something that can be controlled by whatever the situation is happening. Like in this one, we can't control the time, but we can control the distance that we're going away from our house. And the one above, we can't control the time, but the temperature can be affected based off of the time if we have a thermostat. With that one, the pressure in the tire depends upon the temperature. Temperature, we would not be able to control that temperature, but the pressure is controlled by the temperature.